Hello everyone. Today we are here to discuss a problem of LeetCode. The problem number is 202, happy number. First of all, we will discuss what the question is telling us and what are the concepts which we need to understand and solve the question. After understanding the concepts, we will implement it in the coding part and we will solve the question accordingly. First of all, let's check what the question is telling us. It says write an algorithm to determine if a number n is happy. So here we have to write a code to check if an input which is of type number or integer named n here is happy. So the first question which will come into your mind is what is a happy number? So here we have the definition of a happy number. A happy number is a number defined by the following processes. So if a number is happy, then it must follow all these three conditions. Now, what are these three conditions? Let's check. First condition is starting with any positive integer, replace the number by the sum of the square of its digits. So, what is the first condition here? Let me rub it for you. Uh, okay. So, what is the first condition here? Let's suppose we have a number like say 12 and the first digit of any number shall be a positive integer. Let me remove it. It should be a positive integer. Like we can't just take -3 or 0 as it will violate the first condition, the first part of the first condition. Now moving to the second part. Here, as you can see, starting with any positive integer. So, positive integer contains 1 to infinity, positive infinity. Now we have the second part. Replace the number by the sum of the square of its digits. So, what does the second part says? Sum of the squares of its digits. So, what is the answer here? The answer will be 1 plus 4, that is 5. If now we will move to a second condition. Repeat the process until the number is equals to 1, where it will stay. So I hope you are clear with it. If not, then let's see. Repeat this. That means we have to repeat this number. Then now we will check the same thing for 5. For 5 we will have 5 square, that is equal to 25. Then again 25 will go here and we will check for 25. So 25 will become the square of 2 plus the square of 5, that is 4 plus 25, that is 29, and so on until we get 1 here. Then if we will get a 1 here, and we start with 1, 1 will go like this. 1 square and 1. So it will be in a self loop if we get a 1. So that's what it is saying, where it will stay. It will be in a self loop or a loop endlessly in a cycle where it does not include 1. So what does it mean? It means, let's say there is another condition where we are getting some value n, where n can be any of these values which we encountered previously. Like before getting 1, we get any value which we encountered previously and we are not getting 1. Like the cycle is getting followed, but 1 is not included. I hope you're getting. That means by doing so, we are getting the numbers like a range of numbers over A, B, C, D, A, B, C, D, but after that we are again getting A or B or C or D, but we are not getting 1. That means the loop is getting completed without any occurrence of 1. So that is what the second part of second condition is telling us. So now moving to the third condition, those numbers which for which this process ends in 1 are happy. So I hope it is clear now. Those conditions which do not enter in this state but come into this state, this one are called, let me change the color, are called happy number. And these can be called as unhappy. So I hope the concept of happy numbers is clear to you now. If you are confused somewhere, you can pause the video and understand it. Okay, so now we are moving to the question. Now, return true if n is a happy number, okay, and false if not. We have to return a Boolean type, true or false. Now, we have also two examples here to understand the question more clearly. The example says input n is equal to 19, means the user is giving us 19. Now, the output is true. How? That's where the explanation comes to the place. When we apply the logic of the first statement on 19, 19 is broken down into 1 and 9. So 1 square plus 9 square, that is 1 plus 81, that is equal to 82. Now again, when we iterate it according to the second statement, 82 becomes 8 square plus 2 square equal to 68. Again, iteration, it becomes 6 square plus 8 square. Here it is 64 plus 4, that is 68. Here it is 36 plus 64, that is 100. Now again, for 100, 1 square plus 2 square plus 0 square plus 0 square, that is 1 square. Now, if I go again, 1 square plus nothing, that is 1 square again, and it will be in an endless loop where it will only get 1. So here, the third condition satisfies that it is a happy number. So 19 will be a happy number. So that's why the output is true. That yeah, it is a happy number. For 2, it is false. So explanation is not here. So I will just try to give you the explanation for it. So here if we have 2, how will we write 2? We will write it like this. 2 raised to power 2, that is 4. Now we will iterate it again. So 4 is equal to 4 square, that is 16. Now again iterate it. 16, that is 1 square plus 36. 6 square, that is equal to 36. So I'm just writing it here. That is 37. Have you know that was math? So it will go on. Let's go on a little bit and see if we get a loop here. I think we will. 3 square plus 7 square. That is 49 plus 9. That is 58. Now again for 58, we have 25 plus 64. That is 89. Now again for 89, we have 64 plus 81. So 64 plus 81, that is 145. 145, it will be 1 plus 16 plus 25, that is 17 plus 25, that is 42. Now for 42, we will also check, that is 16 plus 4, that is 20. So here we have 20. Now we will get 4. So after a long process, here you can see there is a cyclicity, and during this whole incident, there was no occurrence of 1. That means we are getting a cycle without containing 1. So that's why it is not a happy number according to the third statement. I hope it is clear to you now that how the explanation would look like for this second test case. So now we will move ahead, and here we have been given a constraint. So many people don't use constraint in their code, but sometimes there are some editor cases which can be passed using the constraints only. So it is a good practice to apply constraints on your code. So now I will be implementing the code as the concepts are clear Now I have explained every single concept. If you still have any doubts, comment section is open for you to ask your doubts. Now, first of all, I will get rid of the constraints condition. So for that, I will just implement it. Just a second. Let me implement it. 1 is greater than equal to n and n is greater than equal to math dot power of 2 is to power 31 minus 1. And here, if the constraint is not, if the constraint is fulfilled, then the further code shall be executed. And if not, then we will return false as the desired constraint is not getting fulfilled. But the code will look a bit lengthier to read as we have to, we can read it that here we have applied the constraint, but we have to check for this thing at where the if block is ending if we want to enhance our code or do any changes in future. So for that, we can just take this whole condition as one and we can just apply a not. That means if this condition is not fulfilled, then go back. So that means compiler don't have to go through all those codes, reading the reading part done by the computer can end in just this single line. It will just simply check, okay, this condition, is it true? If it's true, then this not will make it false, and then it will move down after the if statement to execute the further code. If the condition is false, this not will make it true. That means the condition is false, but inside this if it will be true, so it will execute the code inside the if statement. And here we will simply add a return statement which is false to stop the further code execution. So now we don't have to go all the way down to check where the code block of this if constraint is ending. And we can write all the code below it here. Trust me, it's a better practice. So now we have completed it, the constraint part. Now we can apply the logic by which we will be solving the question. So now for the question, do you remember I told you that here we are having a cycle and here we are getting the same number. So how will we compare it? Like we need to store the values in something now to compare it. So for that, here we will take as set. Let me fix it. Set of type integer as we are storing the integer values inside it. You can name it anything. I am naming it scene numbers as we have seen it already. And that's why we are storing it. So now I will create one that has set Now, has set is created. Now, I will go for the address part. Here, as you can see, there's an iteration. Like first, we will apply it on 19, then we will apply it on the result, and so on until we get a desired outcome. So here, for these iterations, we need a loop. So for that, I'm using a while loop because we don't know how long these iterations will go. For example, here in this case, the iteration was a bit long. Here in 12, we don't know where it will end. Like actually, we don't know that. So that's why I'm using while loop because in a while loop we can iterate it multiple times until a particular condition is fulfilled. So we have a condition to fulfill. That's why we are using a while loop here, not any other loop. So now, what are the conditions that we need to make the code exit from this loop? So first of all, I want it to keep running until n is not equal to 1. Like if n is equal to 1, means the updated value of n becomes 1. That means we got the desired output. The number is happy number, so we have to get out of it. That's why I have added this. Also, the second part, this one, of the second statement, if the cycle does not include 1, but there is a cycle for that also, where we use these scene numbers to store the looped variables until we do not get any scene numbers and loop is not occurring, we will keep going on. So here we are checking for it, and now we'll implement the further code. Here we will save the values, all the updated values of n, any new values which we will find, so that if a loop will occur with that number, then we can just get out of it. Now here we need to update the value of n. For that we need to store the date result of these expressions. So for that we will get an integer. Let's name it result for now, and it's better to initialize any value with 0 or null. I mean empty string rather than not giving it a value during initialization to avoid warnings from the compiler. That's why I have given 0 here. So now I will use another while loop to break down the number into digits. So here n is greater than 0 because as you know, if n is 0, then 0 is just not needed to be considered as a digit because 0 plus anything is that thing only. So now I will use result to store the data of the following expression. And I will also write the expression. So first I need the ones digit. So I will just module it by 10 and I need square of it. That's why I'm multiplying it twice. I can use mod also, but that's up to you. I'm not using mod. I'm making it simple. Mod, sorry. I mean math or power, not mod. Apologies for that. Now I will update the value of n by 10 so that the ones place will become the decimal and it will be cut it out as it is an integer, not a float. And then the tens place will come at ones place, and then the loop will run again. And now we will get the other value that is 1 first. Here, when the loop will run, we will get the ones value. The first value is 9, and here we are getting twice. That means we will get 9 square, and we will add to 0, that is 0. The result, that is 0. Then it will become 81. And again, when the loop will run, uh, after updation of n will become 1 because it will be 1.9, and zero point 0.9 will be removed as it is integer. So we will get 1 square added in the result, that is 0, that is 81 already. So now it will be 82, and here n slash equal to 10, it will make it 0 0.1. So 0 0.1 will also become 0 as zero point 0.1 will be discarded as n is an integer. So now n will be 0, not greater than 0. So it will exit the while loop. And then we will just update the result, because as we are watching here, we need to update the result value to n. So here we will update it. Now, after updation, we will just go back, and here the while loop will run again, and we will save the value, the new value of n, which was the result, and we will set the result as 0 again, and we will do the same process again. And this is how the whole thing will work. And after that, when we will get a loop, or we will get a 1, when this while loop condition will not be satisfied, we will get out of it. After that, what we have to do? We have to return something, because here we need a boolean to be returned. So we will return something. Now, there are two conditions. First, the loop is endless cycle without one. Second, it can also be one. Like here we have given both the conditions. First, if n is not equal to 1, that means if n is 1, then it will also get out. If there is a loop without 1, it will also get out. So to handle this thing, just a second, here we need both conditions. Here, so handle these two things, we need something else. So here we will just check when to return true, when we will get a 1. So if n is equal to 1, then we will return true, else we will return false. So if n is 1, is that the reason that we come out of the while loop? If yes, then it will print true. If this one is the reason that there is a loop without 1, it will come out and the result will be false. So that's how I have implemented it. Now I will just run and check it if it's working fine. It is giving me wrong answer. Let's see what is the problem here. Let me check. Okay, so here I'm just reassigning the value. That is a mistake here. So I need to add these two values, no? But here I was just reassigning here, so this was a mistake. Make sure you don't do the same mistakes. So now both the visible test cases are passed. Now we'll submit it. And here we have the runtime is 1 millisecond and the memory usage is 40.54 MB. Here the Runtime is less because hash set uses time complexity of 1, which is less than the primitive data types like arrays and all. But the memory usage is more for hash set. That's why the memory usage is 40 MB. So, if you will ask me, uh, both things are necessary. Like you can't just keep the memory usage low and the runtime also low. One thing will get high if you want to decrease something, but this would be a balanced approach. Nothing should be too high or too low. But if you'll ask me, according to the industrial point of view, the memory problem is getting lesser day by day because they are somehow enhancing the memory usage by cloud storage and all. It is still not too much efficient, but it is getting better. And at the same time, the user or anyone wants to complete its work in lesser time, so the time matters a lot. So focus on time. That's it for today. We will discuss another problem in the next video. See you, take care, and bye bye.